Hi and welcome to example 2 and in fact just before we go on I realized I made a little bit of an error here. This one is force of gravity perpendicular, but this one here should be force of gravity, I'll go red again, force of gravity parallel. So I think I said parallel but I wrote perpendicular, but in any case this way is parallel to the inclined plane and to the hill, and this way is perpendicular. So let's go on to number 2. And number 2 is a rock climber on a cliff. And I think I'm just going to add the fact that this rock climber is stationary. Pick better, stationary. So it's not moving, not accelerating is the important thing. So if the acceleration is equal to 0, then we know that the forces are going to be balanced. And so I just want to make it a little bit easier. Okay, so our system, the thing that we want to draw is the rock climber. So we're going to think about all the forces acting on the rock climber. Okay, so maybe I'll do them over here. Here's the rock climber. There is a force of gravity downwards. So the force of gravity on climber by Earth. All right, now what other forces? Well, there's that rope. That kind of makes sense. It's going to also be the same angle. So this will be a tension force tension on the climber by rope. Now the last one's kind of hard to think about. The cliff is pushing on the person. You might think that the person's pushing on the cliff, but the cliff is also pushing back on the person. So the cliff is going to be pushing that way. And after I draw it, I think it kind of makes some sense. So from the person, I draw the arrow away. Okay, so even though the cliff is on the other side of the person, that's the direction it's pushing. So I'm going to say it's the normal force because it's a surface. The normal force on the climber by the cliff. Alright, so if it is balanced, it's kind of hard to see that this is balanced. Well, now's the time to do the components. Oh, in fact, I guess I should have earlier done what my coordinates are going to look like. So that would be my horizontal and those would be my vertical. Now the components kind of fall into place. This will be my horizontal component, x, and this will be my vertical component, y. So I could refer to that one as ftx and fty, or I can just kind of label them in there. Now when I'm doing my equality marks, I can say, okay, this force is going to be equal to that force. The vertical component of the tension force is going to be equal to the force of gravity. And then this normal force, I'll put 2 ticks on that one, will be equal to the horizontal component of that tension force. Alright, last example. Oh, it's a your turn. I'm just going to add some pieces to the your turn here. So there's a crate. There's a crate here. It's being pulled across the floor by a worker. Okay, so I'm going to put in that this is going to be pulled, say, by a rope. Here, I'll say this is a rope. And it's at some kind of an angle. And I'm also going to say it's being pulled across, and I'm going to say it's at constant velocity. So hint, that means the acceleration is 0. That means the forces are going to be balanced. Oh, balanced. I want you to hit pause now and give it a shot, and then I'll show you my solution to it. So hit pause now. Alright, so here are the easy ones. And again, I'll put in my horizontal and my vertical components, right? Because it's moving this way, so I should definitely have that horizontal and vertical. The tension force and the force of gravity are the easy ones to put in, but then, and when you think about it, what else is there? Well, the floor is also pushing up on it, so I'm going to put the floor up. And I'm going to call that one the normal force on the crate by the floor. The other one is there must be, in order to balance it, this tension force is, and I'll even do this ahead of time, there is a component that is going to the right. Right, there's this component, and there's a component that's going up. There's this x and the y. there must be some force that's got to balance that x to the right. And that force, when you think about it for a while, because it's sliding across the floor, that is a friction force. So I'll draw the friction force. So this FF is going to be on crate by the floor. Okay, now when we think about the fact that it is balanced, maybe I'll use nice big ticks here. This force here is going to be balanced by that force there. Now the tough one is the vertical forces. I actually have two vertical forces going up and one going downwards. So this force here and this force, I'll use one a red tick and one a red circle. Those two added together are going to be equal to this one. So note here, this normal force, the normal force up is not always equal to Fg down. So this is an example of it. If I'm pulling up on the rope, then the floor doesn't have to push up as much to balance out the force of gravity. So this force and this force cancel each other out, and then those three vertical forces cancel each other out. Okay, I hope that was helpful to you, and as always, I will see you in class.